Welcome back, students. In this class we continue area related to circles, chapter 5, exercise 5.3. In this class we continue the seventh problem. In the given figure, this is the figure given. ABCD is a square of side 14 centimeters each with the center ABCD or the centers of the circle. Four circles drawn such that each circle touches externally. So each circle touches externally. Two of the remaining three circles. Each circle touch two of the remaining externally two of the remaining three circles. Find the area of the shaded region. So see here, these are the four circles given and a square is drawn, and we have to find out this area of this shaded region. So first part in the question we'll see first one. So side of the square, since it is a square, side of the square is given as square is 14 centimeters. So since it is a square, each side of the square is equal to 14 centimeters. Therefore, area of the square, here this is the square and one side is given as 14 centimeters. Since it is a square, so all the sides are taken as the same, that is 14 centimeters. So area of the square ABCD is equal to how much? That is side square. What is side square? Side square is 14. They have given 14 square is equal to 196 square centimeters. So this is the first part of the question. Now we'll take, this is the first part of the solution. So now we'll take the radius. So what is the radius here? Radius or radii is equal to r. So this is taken as 14 as d, then will be, that is d by 2, which is 14. So d is equal to 14 here, that is diameter by 2, 14 by 2, which is equal to 7 centimeters. So what is radius? Radius of, therefore radius or radii of 4 circles is equal to 7 centimeters. So now we find out, next step is distance between tangents, which touches circles externally. So distance between the tangents which touches the circles externally. So this can be taken as, so what is a tangent? Tangent means this is a circle. If it goes like this, with a line which touches the circle at one point is called as a tangent. So this is a tangent. Distance between the tangent which touches the circle externally is equal to d is equal to r plus r. So what is r? R is 7 and small r is also 7, which is equal to 14 centimeters. So next is, so after finding this one d, that is the diameter, that is radius plus radius. So next is area of the segment with center A. First part we have to find out area of segment, everything you know, we studied in the previous class, with center A, here this one. So we had what? Two types of segments, So now we have to find out the area of the segments with the center A. With the center A is equal to, now what are the data here? Data R is 7 centimeters. Theta, since it is a square, theta is taken as 90 degrees. Then therefore area is equal to theta by 360 degrees into pi r square. So we have to calculate this 90 degree by 360 degrees into what is pi, 22 by 7 into 7 square. R is 7 square. Finally what we get, simplify this, we'll get 38.5 square centimeters. So this is to find the area of the segment with the center A, that is the first circle. So next step, so we'll continue this. Now we have next one sector we found out. Now therefore next is total area of 4 sectors. Therefore what is the area of one? We got in the previous is 38.5 square centimeters, that is for one circle. Now we have to calculate for 4 circles, so multiply this by 38.5 into 4 will be 154 square centimeters. So after finding this total area of the sectors, we finished this. Next is, so area of last part is area of shaded region. So the region in the center we have to find out. So for this the formula is area of the square minus what? Area of the sectors. Area of the sectors. So substitute what is the area of the square we got, that is side into side square, that is 196, minus what is the area of the sectors, that is the 4. So since square is 1, that is in center, so area is 196. Sectors there are 4, therefore multiply this by, calculate for one circle and multiply it by 4. Then minus 196 minus 154, we get 42 square centimeters. This is the area of the shaded region, that is 42 square centimeters. So this is the complete 7th problem. Now we move on to the 8th one. So 8th problem is given as a track is given. Figure below shows a racing track whose left and right ends are semicircle. So as we know, this track, see, it will be this rectangular form and it will have semicircles at both the ends. So this is a track and this is a rectangle and these are semicircles. So we'll read out the question. The distance between the two inner parallel lines of the segment is 60 meters. These two parallel lines is 60 meters and they are each 106 long. So we each have 106 long meters. If the track is 10 meter wide, so it is a 10 meter wide. Find the distance around the track along its inner edge, the area and the area of the track. So they are given question as, if the track is 10 meter wide, find the distance, that is the first part is the distance around the track along its inner edge and the area of the track. So we'll solve this. that is the distance. First part is the distance around the track along its inner edge is equal to, that is first part we have to take distance around the track along its inner edge. First is we have to take that is the straight line AB. So AB, next are the parallel lines, we can say arc, that is AB. Then arc is which one? That is BEC. BEC, this one, first track, the distance, the line, then BCE, this point is E. So first line, then this arc, again the line CD, this one, CD plus again the arc, this arc, that is area. So I will write here area of the arc. So here also area of the arc. Which is the arc here? That is AFD or DFA. So this is the formula to find out the distance around the track along its inner edge. So this line plus this arc, this line plus this arc, only the inner part of the track we have to take. So next is, what is AB? They have given, that is 106 meters plus the arc. What is the formula? That is half into 2 pi r square plus again CD is given as 106 meters plus area of the arc DFA is half into 2 pi r. Finally we will substitute this 106 plus half into 2 into 22 by 7. What is the radius? Radius is 30 for first one. This one, since this is 60, the inner part is 60 meters and the outer part is 80. Therefore this is 60, means we have to take off 30. I have written everything completely in the figure. So this is 30. So radius we have to take 30 here in the first inner part. So 30 plus again one more arc is, again CD is what? 106 plus again half into 2 into 22 by 7 into, what is the radius here? Again it is another arc, means again we have to take 30. So now simplify everything. We will get, add these two first, add these two, 106 means how much? 2 112. Then what is the common things? Plus of 2, this cancels, again 22 by 7 is common, again 30 is also common. Just add all these things, we get plus, we get 2 into 22 by 7 plus everything is multiplied by 2. Therefore 30 we will get 212 plus 1320 by 7, which is equal to 2804 by 7 meters. This is the area around the track along its inner edge. So this is only taking the inner part. So this is the two lines, parallel lines, then the two arcs. So we got the answer as 2804 by 7 meters. So next is So after this, the area of the track, that is the second part of the question. That is, we finished finding the first part of the question, the area of track. So what is the area of the track? For this area of the track, so area of GHIJ, so I'll just minus, so I'll write down once again this one. This is the track roughly, so this one, so this is the inner. Next, this one is, this is GHIJ, this is the, then this is ABCD. So what is the next part? Next part is, so area of GHIJ minus, then area of, so this is a rectangle, so these two are semicircles, so these two are semicircles and this is a rectangle, so this is what, minus, next is area of one more rectangle, this one we have to consider since we are finding the area of the track. So this rectangle minus this rectangle, area of what, another is ABCD, then minus this, after this minus area of the semicircle. So we have to take here two semicircles, here two semicircles. So what are the semicircles? So for this point is E, then this point is E, this is K, outer part is K, this is E, then here also one more is, that is F, and this one is I. So these are the four semicircles. So now we'll take the first pair of the semicircle is area of semicircle, area of the semicircle HKI, this one, the outer part of the semicircle HKI, minus again area of semicircle, area of the semicircle, this one BCI, this semicircle minus this semicircle, that is BEC. So this is BEC. Next is again plus. So here we have to put plus, this rectangle minus this rectangle, then this semicircle minus this semicircle, again this semicircle minus this semicircle. So there are how many? Two rectangles and four semicircles. So these two minus, again plus, these two minus, again plus, again plus, again we'll take another pair of semicircle, area of the semicircle, which one? That is GHIJ. Once again I will write GIJ, this outer part of the semicircle, again minus, again inner part of the semicircle. So area of semicircle, that is what? That is AFD. So here inner part AFD. So we finished writing all the formulas. Now we have to substitute the values. What is the area of the rectangle? GHIJ is length into breadth. So what is the length given as 106 into, so the outer part is 106 for both the rectangles and inner part is 180 and 160 width. So 160 into how much? The outer part of the rectangle is 80 minus again the inner part is 106 into how much? 60 plus the semicircle HKI is off into what is the formula? Pi r square. Pi r square. So first I will write the formula and it will be easy. Length into breadth, again length into breadth, plus half into this one and pi r square, plus again semicircle means all same, half into pi r square, plus this is minus, again plus half into pi r square, plus inside the bracket minus half into pi r square. So this is the formula. So let's substitute the values. 106 into 80, length into breadth of the outer rectangle. Inner rectangle is 106 into 60. Next is again this is plus, we have to write, then half into 22 into 7. What is radius here? The outer circle is 40 and means this one 60 divided by 2, again this one 80 divided by 2, 40 square, plus again half into 22 by 7 into 30 square. This is minus this, again now plus half into 22 by 7 into again the outer semicircle minus half into 22 by 7 into 30 square. Now everything we have to simplify. So simplify this. So we'll get, so 106 is common, take outside, 80 minus 60, then plus 22 by 7 is common and 40 and 30 is common, therefore we get 40 square minus, that is a square minus b, a square minus b square, 30 square will get. Therefore this can be written as, this simplify, minus 20 into 106 will get 2120 plus 22 by 7, then this can be written as 40 plus 30 into 40 minus 30. So again simplify this, we get 120 plus 22 by 7 into 70 into 10. So therefore this is 2120 plus, simplify all this, will get 2200, which is equal to, add these two, 4320 square meter. So therefore total the area of the track is how much? 4320 square meters. So this is the solution for which one? That is the 8th problem. So we'll continue the next problem in the next class. If you have any doubt, comment me, subscribe my channel, share and like all the videos. Thank you.